So part A, which says determine the number of solutions for each system. So we could take a look at number one, and we could just graph these equations, and we can try to see if they are on top of each other, if they are parallel and separate, or if they are different slopes and they intersect once. But there are easier ways to do this. So what we could do is we could actually just compare the ratio. So if we compare the ratio of the x to the y, that ratio of the x coefficient to the y coefficient will in the end determine the ratio of the slopes. Not necessarily slopes just because of the way it's written, but the ratio is how we calculate slope. And that will affect the coefficients on x and y. So looking at the coefficients, we have a 2 to 3 ratio. And so this is for 1. So for 1, we have a 2 to 3 ratio and a 4 to 6 ratio. Well, these simplify to the same ratio. So they are parallel. So same ratio. Therefore, they are parallel lines. Now, how do we determine if something's parallel or they are the same? Well, if the third coefficient, if the constant term is in the same proportion as the x's and y's, so we're doubling, notice that there's a doubling from one to the other. There's a doubling factor from going from the top to the bottom, that's times 2. Every coefficient is in the same order and it is doubling, means that these are really the same equation. If I just multiply the first equation by 2, I'll get the second equation. Well, that means then that these are exactly the same lines, which means that they'll graph on top of each other. So we have a 2 to 3 to 4 ratio of the coefficients. It's equivalent to all three terms are in the same proportion. They are all a times 2 proportion or in the same ratio. So when all three terms are in proportion, they are the same equation, and therefore have infinite solutions. Infinite solutions here. Okay? So in example 1, they are infinite solutions. So taking a look at 2, we can see that the x and y's are in proportion with each other. So the x coefficients and the y coefficients are in the same ratio, 2 to 3, 4 to 6. However, that third coefficient is not in the same ratio. Okay, so these are not in the same ratio. That is not a times 2 ratio. Therefore, they are parallel, but not the same. Okay, so for 2, these are parallel, but different. Therefore, 0 solutions. Okay, and then lastly, if we take a look at number 3, okay, so I'm just going to circle that there. If we look at 3, we can see that the ratio of the x's to the y's are in a different ratio. We don't even need to check the last term because we know that the coefficients, are are in different proportions, have different ratios. Therefore, not parallel, and they must have one solution. Oops, maybe I'll just write that text line here. They must have only one solution. Okay, so how can you compare corresponding coefficients to help you determine whether a system has no solution, one solution, or infinite solutions? So no solution means is a situation where they're parallel. Okay, so it's gonna be this one here. Their coefficients are in proportion, so they're parallel, but the constants are in different proportion, therefore not the same. No solution. One solution, we take a look at the coefficients, and they are not in proportion. They don't have to share the same ratio. So therefore they are different slopes, meaning they have one solution. And infinite solutions would be a situation where all three coefficients are in proportion to each other. That would be this case here. Therefore, they're parallel and the same, therefore infinite solutions.